Hi folks, welcome back to the Pre-Cal 40S videos. In this one, we're going to be beginning chapter 5. We're going to look at trigonometric functions and graphs. But first, I want to remind you of the good old days of our unit circle. Now, here's our unit circle. You can see this image in front of you. It is a interactive, I guess you can call it an applet. It's from mathisfun.com. And what you see here on the left-hand side is you see the unit circle. So I'm going to move the mouse around so you can see the points, the coordinates of the unit circle. And then what happens when I move this around, you see the blue line actually follows the cosine, and the red line follows the sine, which is the y values on the unit circle. And then the green line is actually following the tangent x. So here, you know what? The best way to do this is probably go to the website yourself and actually just kind of explore the coordinates of the unit circle, and you could kind of follow the path and see how it relates to the graph of sine x, cosine x, and tangent x as it relates to the unit circle. So we're basically taking the circle, we're folding it open so that we could see the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. And if you want, you could click on these buttons down here and it'll change it from radians to degrees. This will just remove the quadrants, and this button here for the coordinates will just remove the coordinates so you can kind of see it with a little less junk all around. Okay, so have some fun with that, play with that, and then what I'm going to get into right now is I'm going to get into the notes. So here are the notes. It's chapter 5, trig, functions and graphs, outcome T4. This whole booklet is all of outcome T4. Okay. All right. Now, that's the website. That's the URL that I used that I was just at. So you can take a note of that and go there. Here we've got a few new words. Periodic functions. Now, this is a function that repeats itself over regular intervals or cycles of its domain. And then a period is going to be the length of the interval over which a function travels one full rotation or cycle, the distance from one point to that exact same point again. Here for amplitude, this is the vertical distance from the horizontal central axis, the maximum or the minimum. All right, so it's the highest it goes in the y or the lowest it goes in the y. Note that the central axis is not always the x-axis. All right, so sometimes when we're going to start having shifts, it might be shifting up or down, okay, and then that's going to change. And for sinusoidal functions, these are all sinusoidal functions that we're looking at in this sine and cosine right here. Okay, so I've taken those coordinates and I've made a little table of values. And so what I'm going to do is I'm going to highlight the 0, the 2, the pi by 2, the pi, the 3 pi by 2, and the 2 pi for both sine and cosine. And in red, I have graphed sine, and in blue, I have graphed cosine. And so we're going to look at the similarities and the differences between the two functions. All right. Now, the graphs that we see, they're identical except for a shift or translation of pi by 2. And that's either to the right or the left. You can look at it depending on what you fancy. The two graphs they're both periodic and they're both continuous, and they are both considered sinusoidal graphs. So if a question ever says something about sinusoidal graphs, it's either talking about a cosine or a sine. Properties of the two, they both have the same domain. They both have the same range. The zeros are different. So the zeros, x-intercepts, for instance, for sine, they end up at every multiple of pi. And for cosine, they happened at the pi by 2 plus a multiple of pi. The y-intercept on your sine is 0. The y-intercept on your cosine is 1. And the max value for both of them is 1 and negative 1. They both have amplitude of 1, and they both have a period of 2 pi. Okay, so one thing that you need to get good at is drawing a quick sketch of both of those. So I have taken the liberty of already putting onto my scale 1 and negative 1, and then I'm showing the intervals of pi. So pi, and then this is pi by 2. So for sine you always want to remember to start right here, and you're going to cross right here. These are your intercepts, and the highest that it's going to go is midway here, and then midway over here. So then you want to draw a nice curve. You want to keep it looking like basically a little bit of a circular type of look to it. Okay, and then it's gonna, it kind of works nice when you feather a little bit. This bump looks not so great, so try to fix that one. Okay, and over here, this one, cosine starts at the 1, and its zeros are here, and then it bottoms out there, crosses through here, and then comes back there. So this, you want to keep it looking like a nice curve each time. Okay, so there you have it, a quick sketch. You want to try to keep it as smooth as possible. I'm trying to do 10 things at once right now, so my curves don't look that great. Okay, now for the next thing, we're going to look at transformations on these guys. So it's important that you have these stuck in your brain and you know what the parent function, we're going to call these the parents, look like, so that you can do your transformations. All right, so the next page, we've got our transformation. We're just going to do the amplitude and this B, the A and the B. The A helps us decide what the amplitude is, and that's the vertical stretch. So it's how long it is, like this. And then this B, it's used to determine the period, but it's not, be careful, it is not the actual period. So it tells you how wide or narrow our functions are going to end up. What I've done is I have, oh wait, here, this is how you actually figure out what the period is. So your B value, whatever your B value is, you always take 2 pi and you divide it by your B, or 360 degrees and divide it by your B. So let's jump into some examples. What I've already done here for these is I've drawn in pencil the original sine x or cosine x, depending on what my base is. So here my base is sine, so I've already drawn sine x, and I'm going to apply this vertical stretch by 1/2. So vertical stretch by 1/2, or I could look at it as a compression. All right, so it's going to be half as long, I guess you can say, half as tall as the original. So it's only going to end up going about from here to here and here. So I can just draw my sine so that it looks like that now. Okay, so in pencil I've got the original, and in my marker I just drew in 1/2 sine x. All right, let's look at cos x here. So this is my original from 1 to 1, my amplitude. Now here, this 3 out in front, this is going to be a vertical stretch of 3. So it's going to be 3 times as long or as tall. So I'm going to start my cos from here, and I'm still going to go through this as my x-intercept. This here, down here, this is going to go 1, this is going to go down to -3. And so it'll be there, there, and then I'm going to end up back up here at the 3. So let's draw in our cosine. It's a little, I'm living on the edge, kind of dangerous using a marker to draw these, because if I make a mistake, then it's forever there. Okay, so, all right, so there you go. There you have it. This kind of comes back up like that, and there's your 3 cos x. Now, sine 4x. Now, you have to do a little work for this one. Now, the period on this one, we have to use our 2 pi, and then we're going to divide it by, b, and in this case, b is 4. So 1 period is actually only going to be pi by 2. So that means my entire cycle has to go from 0 to pi by 2. So it's going to be really squishy. So I have to do one entire full cycle. So you know what? I'm going to do it in pencil because I'm kind of scared. All right, so sine. Sine starts here. It goes up. This is my pi by quarter. It's going to come through in there. And then I'm going to go back up and there. Okay, so I'll put that in marker because that's not too bad. Right here. And then come back there. Okay, so that is my sine 4x. And then cos of x divided by 2. So here, this means that my period is actually going to end up being much bigger. So I don't really like the scale that I have drawn here. I wasn't thinking about the question as I was drawing it. So you know what I'm going to do? I'm going to change this to 2 pi, and I'm going to change this to 4 pi. Well, that's actually what the drawing is if I change my scale. So let's, I guess I kind of did a little bit of a shortcut there, hey? That was kind of fun. So just to verify, b equals 1/2, and then my period is going to be 2 pi divided by 1/2, or I can change that so that it's times the reciprocal, which is 2 over 1, and then 4 pi. So that is 1 period. So I started my cosine here and I end my cosine here. So that was kind of a little easier way to draw it. I just changed my scale in order to have my drawing from my original. Okay, well, there you have it. If you want to actually see it in comparison to what the original cosine would be, you can do that too, but why bother? Okay, so here are some examples. I'll stop talking as soon as you press stop or the video runs out, and hopefully you'll try some questions. Okay, have fun. Bye.